Hey, I'm Josh. I just started working on a game called Mansion. In the last video, I just explained what the game will be about, so in this video, I'll do some actual development. So far, I have a working lighting system with transparency support, and a simple player controller, and I also have a framework for making the camera follow the player. I'm currently playing the time-lapse of me adding the lighting system into the new project. You might notice that I got it working awfully quickly, and that's because I copied the system from an algorithm I developed a couple of months ago. I originally wrote it for the Godot game engine in its built-in GD script, but learned that the post-processing capabilities in Godot aren't as flexible as I would like yet. I then downloaded Unity and re-implemented it line by line into C#. I'm now a lot more familiar with C# than I was then, but I already knew Java and C++, and it feels like somewhere between those two. The hard part has been learning how Unity works. I found Godot to be quite intuitive with its everything as a node or a scene view of the world, so Unity felt like a bit of a complicated mess with its GameObject component prefab system, but it doesn't seem so bad anymore after using it for a couple of months. I moved on from making a 2D game a couple of months ago to making a 3D game, so now I have a couple of months of experience with Unity's 3D half, and I can just apply basically the same principles to the 2D half. I actually had the basic idea for Mansion a couple of years ago, and it was originally going to be an Android game with procedurally generated levels. I never wrote the idea down or anything, but what I'm going to make now is basically inspired by that original idea, and it seemed like it would work well as a desktop or console game. I'm quite happy with how my custom 2D lighting system works, so I might make another video on that, with an overview on how to implement it yourself. I also got it working in the scene view in Unity's editor, which I thought was actually a pretty poorly documented process, so I might include that in my lighting system video. There actually seems to be 1,000,001 ways to make custom post-processing related things in Unity. The way I've done it is by having a second camera that's a child of the main camera, and I used the child camera to render just the layer with the lights on it. And it uses a shader to blend the final texture of all the lights by themselves with everything else without the lights. And so you get a final image that has the base color multiplied by the light color. The light layer rendering is triggered by the onRenderImage callback on the main camera. To get this working in the scene view, I grab the sceneview.lastActiveSceneView.camera object. I then automatically add a child camera to the scene view camera, and then also automatically add my post-processing component to the scene view's main camera. This is just one of the many ways that I think it's possible to do this in Unity. Other methods of doing the post-processing might include using command buffers instead of a second camera, copying the techniques used in the post-processing asset, or using a custom scriptable render pipeline. But making any of these work well in both the game and the scene view is pretty unclear to me right now, so I'm going to just avoid that. Moving on to the player controller, what you see here is a little demo level that I've made that demonstrates the lighting and the player controller and the camera following system. I made the player with a 2D capsule collider and a rigid body. The idea is that you can walk up to a wall and the player will turn to face it. So let me demonstrate that. So it does in fact turn to face the wall. You can get around little edges like that. The physical values aren't quite right yet, but I'll obviously be fiddling with those for the entire development of this game. The rigid body is free to be knocked about by walls and stuff, but it has linear and angular drag to slow it down quickly. When you try to move in a certain direction, it slowly interpolates the velocity towards the desired movement vector, and it interpolates the body angle towards the movement direction. So you can see that. This allows the physics system to have some say over the player's movement too, so it can automatically line up with walls. I also interpolate the head towards the mouse direction, but restricting it so it doesn't turn backwards relative to the body. As for the camera snap system, it doesn't really do anything right now, but I have a component called camera snap, which you can see right here, and I can add it onto any component in the scene. It registers itself with the main camera, and the main camera calculates each frame where in the world it should be and how zoomed out it should be. It can be configured with a priority checkbox to say whether it affects globally or if it affects locally relative to the radius value. So It will only take effect if it's within 5 units of a player, for example, except in this case it doesn't matter where it is because isGlobal is checked. Also, it is the player, so it'll always be near the player. If two things have the same priority level, such as player, then the camera is supposed to zoom out so that you can see both the player and the other object. If something has a higher priority, then the camera will just move away from the player altogether. Say you walk up to something important, like a door or a monster, then once you get close enough to it, the camera will zoom out so that you can see the player and the monster in the same view. So that's about it for this video. I recorded a time-lapse of me implementing the player controller system, so I'll stick that on the end of this video with some music in the background. If you want to see more of this, then please subscribe, and of course, like this video if you want to make me feel good. So at this point, I discovered my lighting system was broken and spent half an hour trying to fix it. The problem was that I changed a tool function to use degrees instead of radians, and I didn't realize that the lighting code was using it, so it obviously ended in disaster. Unsurprisingly, version control helped me actually figure it out. Use version control, please.